Welcome back. Now we're gonna be talking about the mole concept. If you recall, the mole is an amount of a substance which contain how many particles? 6.02 times 10 to the power of 23 particles, and these could be electrons, ions, atoms, or molecules. Okay? This number is also known as Avogadro's constant. Good job. So now we have the relative atomic mass, which is the sum of the relative atomic masses of each atom within the molecule. So for carbon dioxide, we have the mass of carbon, which is 12, and there's only one atom of carbon, so you multiply that by 1. Okay, and then you have the number of atoms of oxygen, which is 2, and you're going to multiply that by the mass of oxygen, which is 16. And then what you're going to do is you're going to add the two products, and that's going to give you your RAM, your relative molecular mass, which is 44. That's it. So now we're going to figure out what the mass of ammonia is. So for the mass of ammonia, we're going to get the mass of nitrogen, and if we look at the periodic table, nitrogen is right over here, and the mass of nitrogen is 14. Remember, the mass number is the top number. So I'm going to say 14 multiplied by the number of atom of nitrogen, which is 1, multiplied by 1, that gives me 14 grams. Next, I'm going to move on. I'm going to do the same for hydrogen. So the mass is always at the top number. So the mass is 1 for hydrogen, but there is how many atoms of hydrogen? There are 3 atoms of hydrogen, so I have to multiply that by 3. Alright, and that's going to give me 3. And then what I'm going to do is I'm going to get the sum of these two products. So 14 plus 3 is going to give me 17, and that's my relative molecular mass. Moles and volume. Okay, so only gases can be compressed, and the volume of any gas is always written at a certain temperature and pressure. Okay, so why can't solid and liquids be compressed? Solid particles, they are too tightly packed together. There's little space in liquids, alright? And therefore, they cannot be compressed any further, because being compressed means you have to push them towards each other, and if there's so little space, it's impossible. Alright, do it in a solid, and a little bit could happen in a solid, but in a gas, because the particles are so spaced out, we can easily bring them closer together. What is the volume occupied by a gas? We know that volume is the space occupied, right? So at room temperature, which is room temperature and pressure, 1 mole of any gas, I don't care what gas it is, it will occupy the same amount of space, which is 24,000 centimeter cube or 24 dm cube. And 20 degrees Celsius to about 25 degrees Celsius is room temperature. At standard temperature and pressure, 1 mole of any gas will occupy a volume or space of 22,400 centimeter cube or 22.4 dm cube of space. Any gas. So now we have to find the mass, volume, or moles using an equation. The first step is we have to make sure the equation is balanced. Next is we have to underline the given mass, volume, or moles, and the substance whose mass, volume, or moles has to be determined from the equation. So most first step is we have to underline what is given to us, what mass is given to us, okay? What volume or what moles is given to us in the question. The next thing is we also have to underline what it is that they want us to find. What do they want us to find? The volume, moles, or mass that they want us to find. We have to underline that. And then we're going to call this X, but we have to give it a unit. If it's mass, you give it the unit grams, volume, dm cube, or moles, if it's moles. The next thing you have to remember is that this information is then going to be placed inside of the equation. All information obtained from the equation is going to be placed at the bottom of the substances. So any information that you get from the equation, if you're not sure where to put it, just put it. You're going to have to put it at the bottom of the equation, and it has to go at the bottom of the substances that are involved. Next step is you have to Calculate the relative molecular mass for the substances involved if mass is at the bottom of the equation. So if mass is at the bottom of the equation, all right, they give us a certain mass of that substance that's used in this scenario, in this equation. However, for the top part, you need to give us the overall mass of that substance. And we get the overall mass of the substance by looking at its RMM, by using the periodic table. The next thing is use 24 dm cube or 22 dm cube, 22.4 dm cube if volume is placed at the bottom. So if volume is placed at the bottom of the equation, that means it's telling you they're either giving you information on the volume, or volume is X. And at the top of the equation, you need to state the volume of a gas. And we know that the volume of a gas is either 24 dm cube at room temperature or 22 dm cube, 22.4 dm cube at standard temperature and pressure. And next thing is we have to use the coefficient. So remember we use numbers to balance the equation. So those numbers are called coefficient. So if it's moles that we have at the bottom, at the top we need to include the coefficient. All right, and all of these information, like I said, it will be placed at the top of the substances that are involved. So now we have a question, all right? So how do we identify when we need to use an equation to solve our questions? Okay, first of all, it will give us an equation, and then all right, they'll give us an equation. Sometimes they ask you to use the equation, but you could also look at the language. They always tell you, they give you a story, they give you where they tell you they tell you what's being reacted together, and then they tell you something is being produced. Okay, so that's how you know you're going to use an equation. So let's look at it. So here we have, they want us to find the mass of magnesium ribbon used to produce 0.2 grams of magnesium when it was burnt in oxygen. So what was given to me is the 0.2, what was given to me was to produce 0.2 grams of magnesium when it was burnt. So producing 0.2 grams of magnesium tells me that magnesium here is a product. So this 0.2 has to go at the product side. All right, and then Alright, and then my X, what do they want me to find? They want me to find the mass of magnesium ribbon used. And they're telling me that magnesium ribbon was used, so I know it's a reactant. So my X, see I put my X, I'm also going to put grams because gram stands for mass. Okay, now what do I put at the top? Remember, at the top, if you have mass at the bottom, at the top you need to state the mass for that substance, okay, that overall mass for the substance, okay. So here we have grams, so we need to give the overall mass for magnesium, and we find that mass by using our periodic table. Good job. All right, using our periodic table. So the relative molecular mass of magnesium here, I have a 2 in the front, so I can't disregard it. I have to multiply that 2 by the mass of magnesium, which is 24. And overall, I got 48. And then, all right, so magnesium right here, right? And we know that the top number is the mass number, so 2 times 24 gives me 48. The amount of magnesium oxide, so magnesium oxide, I have a 2 in the front here, times 24, which is the mass of magnesium, plus 2 again, all right, times the 16, because the 16 is the mass of oxygen, all right, and I'm going to get the sum of the two products, which is going to give me 80 grams. So this is why I have 80 grams up here and I have 48 grams here. So for X grams at the bottom, I need to also, if I have X grams at the bottom, I need to state what is the overall mass of magnesium. And I find that by using the periodic table. Over on this side, I have 0.2 grams of magnesium oxide, but what is the overall mass of magnesium oxide? I find this by looking at the periodic table. All right, so that's our first step. Now the next step is we have to cross multiply. Good job. We cross multiply 48 multiplied by 0.2 divided by 80 grams times xg. Okay, so it's always easier for us to just go ahead and remove the numbers from all of these symbols and just put it somewhere neatly, so it's a bit easier, okay, for you to work with. So 48 Same thing though, 48 times 0.2 divided by 80 xg. That's it. And then when you put that in your calculator, the answer that you should be getting is 0.12 grams. And that is it. So now we're asked to calculate the volume. So I would have went ahead and I would have calculated what it is that they would have given me. Okay. So what did they give me in this question? They gave me what volume of carbon dioxide will be released from the decomposition of 50 grams of calcium carbonate at STP. So they would have given me the decomposition of 50 grams of calcium carbonate. So decomposition means that it is a reactant. It's being broken down as a reactant. All right, so I have 50 grams of calcium carbonate, and then I also have an X, which is what volume of carbon dioxide. So that's my X. Okay, and it tells me will be released, so I know that that is going to be a product. So I'm going to put it as a product, carbon dioxide. I'm going to find carbon dioxide as a product, and I'm going to put XCM cubed there. The next thing that I need to do is, what's the next step? Okay, so we have mass. They give us mass of calcium carbonate that was decomposed in the question. But we need to, so at the top, what are we going to put? We need to put the overall mass for calcium carbonate on the top. Okay, so what's the overall mass for calcium carbonate at the top? All right, so how do we find that? We are going to go ahead and we are going to look for the masses of calcium and carbonate, and we're going to use that. We're going to do that by looking at the periodic table. So what's the mass of calcium? The mass of calcium is group 2, the top number, that would be 40. And then we're going to add that with the mass of carbon, which is 12. And we're going to add that with the mass of oxygen. So oxygen is over here, and it's 16, but there are 3 atoms of oxygen, so we have to say 16 times 3. All right, so then what you're going to do is you are now going to get the sum. You're going to get the sum of each of these products, and that is going to be your RMM. Your mass for calcium carbonate is going to be 100 grams. And then look, so we have XCM cubed on the right, so at the top we need to put the volume, the overall volume occupied by carbon dioxide. We know that every gas occupies the same amount of space. All right, we just need to determine whether it's STP or RTP, which they will give you. If they don't give you it, that means it's at RTP. So at STP, we know that the volume occupied is 22.4 dm cubed, so we need to put that there. So that's it. The next thing I'm going to do is I'm going to take my numbers and put them over here neatly. All right, and then I'm going to cross multiply. 22, I'm going to cross multiply. All right, so I should have 22.4 multiplied by 50 grams divided by 100 grams. Yeah, that's what I should have. And the answer you should be getting is 11.2 dm cubed. That's it. So now we are given another question where they ask us to find how many moles of oxygen will react with 18.6 moles of hydrogen to produce water. So the first thing you should have done is you should have underlined what they give you and what they want you to find. So what did they give us? They gave us 18.6 moles of hydrogen. So they told us that they gave us 18 moles of hydrogen, but is this a reaction or a product? Let's look for the hints. And then they also gave us, they want us to find how many moles of oxygen, all right, will react. All right, so how do we know which is which? So 18 moles of hydrogen, where do I put it? How do I know where to put it? Let's look for the hints. So how many moles of oxygen will react? That word react is telling us that it is a reactant. All right, how many moles of oxygen will react? So that's our X, right? And then react with 18.6 moles of hydrogen. So it's going to react with hydrogen. So that means hydrogen, 18.6 moles of hydrogen is also a reactant, okay? So we're going to put that information inside of our equation, okay? And what was our next step? All right, so if it's moles, at the bottom, what do we put at the top? We put the coefficient, yeah? So put the coefficient for this for this hydrogen, which is 2, and the coefficient here is 1. That's it. Next step is we cross multiply. That's it. 48 grams multiplied by 0.2 divided by 80 grams. And the answer you should be getting is 11.3 moles. That's it.